Radical, unanticipated developments in electrification, storage, distribution, and other technologies are transforming not only the way energy is produced, but also the way it is used. Like the transformation in energy production, these advances in energy consumption are transforming economies and creating new opportunities to protect the climate and improve our lives. In the previous commentary, we examined the impact of the Greentech revolution on the production of energy. But energy production is only one side of the Greentech revolution. The other is providing that energy where it is needed, when it is needed, shifting energy consumption from fossil fuels to electricity, and using that energy more efficiently so less of it is required. As the FT wrote in The Reshaping of Energy Consumption, just as important as the development of new wind and solar farms to generate electricity without carbon dioxide emissions is the overhauling of vehicles, heating systems, and factories. After energy has been produced, it often must be stored until it is needed. Enter the Greentech revolution in energy storage. Over the past 15 years, the cost of energy storage has dropped 95%. In 2025, Chinese batteries appear to be headed for a further 30% decline. In 2025, the world was expected to add 80 gigawatts of grid-scale storage, 8 times as much as in 2021. More change is at hand. For example, sodium-ion batteries are safer than lithium batteries and do not require destructive extraction of materials like lithium, cobalt, phosphorus, and copper. Materials for sodium batteries are far cheaper than those for lithium batteries. BYD opened a sodium-ion battery factory in 2024 and is producing a large sodium-ion battery energy storage system called MCQT. Sodium-ion storage is likely to make it possible to replace fossil fuels with electricity in such until now intractable areas as heavy trucks and long-distance shipping. This is only one of several impending battery breakthroughs. For example, long-duration energy storage is increasing today's typical storage time of about 4 hours to many times that long. Google recently announced investment in long-duration energy storage. Toyota has developed an all-solid-state battery that provides electric vehicles with smaller, more durable batteries that charge in minutes and deliver longer ranges between charges. After energy has been produced, it needs to get to where it is needed. Led by China, there is a revolution in long-distance power transmission. One ultra-high voltage Chinese power line stretches more than 2,000 miles from the sparsely populated far northwest to the populous industrialized southeast, the equivalent of sending electricity from Idaho to New York City. This is one of 42 long-distance power lines, each able to carry more electricity than any utility transmission line in the United States. China's transmission technology is far more efficient than others, and China plans systematically. It is now building the world's first nationwide grid of ultra-high voltage power transmission lines. At the opposite end of the scale, microgrids are providing new ways of distributing energy locally. According to the National Renewable Energy Laboratory, a microgrid is a group of interconnected loads and distributed energy resources that acts as a single controllable entity with respect to the grid. It can connect and disconnect from the grid to operate in grid-connected or island mode. It can therefore keep a local grid running even when the wider grid fails. Microgrids allow coordination and synergism among small-scale local energy infrastructure like generators, renewables, and batteries. That allows them to save costs, reduce the need for energy, and make money by selling excess electricity. Microgrids are now being used in hospitals, universities, neighborhoods, and many other venues. In Petaluma, California, for example, the newly constructed 131-unit Meridian at Petaluma North Station affordable apartment complex includes a solar and energy storage microgrid. The Net Zero project will generate and manage all its energy on site. Its microgrid includes a 1 megawatt solar array consisting of rooftop-mounted panels and solar canopies in the parking lot. A storage battery is designed to support the complex for 3 to 4 days during a power outage. Parking spaces with bidirectional electric vehicle chargers directly wired into the microgrid will allow electric vehicles to charge from the solar array and provide electricity back to the building when needed. The largest shift so far from fossil fuel burning to electricity is the replacement of gas guzzlers with electric vehicles, EVs. Not only do EVs use electrons rather than gasoline, they use 2 to 4 times less energy than their fossil fuel counterparts. Sales of EVs have been rapidly growing globally, increasing by over 33 times from 500,000, 1% of all car sales in 2015, to over 17 million, more than 20% of all car sales in 2024. EVs now account for almost half of all car sales in China, 20% in Europe, and more than 10% in the USA. EV sales in Asia and Latin America increased by over 60% in 2024 to almost 600,000. Electric vehicles made up 80% of Norway's new car sales last year. Electric car sales in 2025 were expected to exceed 20 million worldwide, more than a quarter of all cars sold. EVs are only part of the Greentech transformation of transportation. Electrification and system reorganization have the potential to transform rail transportation. In the English town of Aldershot, solar collectors are directly delivering electricity to drive trains. The developer says, if you are a railway, this is the cheapest electricity you can buy. In China, 30,000 miles of high-speed rail lines run on electricity. Buses, subways, light rail, and other public transit can now be provided at far less cost than auto transportation due to electrification and technological improvements. Due to the emerging battery technologies, ships and planes may be electrified at competitive cost. At the other end of the scale, electric bikes providing micromobility are already a rapidly expanding transportation niche. One recent example is a 4-wheeled electric bike for individual and commercial cargo hauling. Agricultural techniques are turning farms from producers to reducers of greenhouse gases. For example, regenerative agriculture provides farming and grazing practices that withdraw carbon from the atmosphere by restoring degraded soil biodiversity. New technologies are allowing farmers to grow crops underneath solar panels. The New York Times recently featured an agrivoltaics installation in Houston, Alaska, adapted to the farm's extreme northern location. The rows of panels on the 45-acre site collect solar power on both front and back in order to capture the maximum amount of summer sunlight as the sun dances across the horizon all day and all night. The electricity produced from such agrivoltaics can run farm equipment and be sold to provide an extra source of income for farmers. The food produced can help meet local food needs. As in so much green tech, China is creating radical advances in agrivoltaics. For example, the Chinese company GCL says it has combined 4 new agrivoltaic technologies. Bifacial solar panels harvest sunlight from both sides, enabling them to assume a space-saving vertical position when needed. Tunable solar panels that enable more or less light to pass on to crops can be adjusted to a range of 15 to 40% light pass-through. Elevated racks can be raised to 9 feet with tracking capability to optimize the sun collecting angle. Advanced system management integrates meteorological data, crop growth sensors, inverter analytics, and AI algorithms to optimize module tilt and irrigation schedules. There are thousands of Greentech goods, services, and systems that have been introduced or are in development around the world that will increase efficiency and reduce greenhouse gas emissions, far too numerous and diverse to review here. For a knowledgeable review, see Mark Jacobson's Still No Miracles Needed. A few of the most important additional sectors of Greentech advance. Climate-safe factories are now being built around the world. For example, Ford has opened a carbon-neutral assembly plant in Cologne, Germany, to produce electric vehicles for the European market. According to Ford, the plant uses digital advancements that connect machines, vehicles, and workers, including self-learning machines, autonomous transport systems, and big data management. New technologies are even reducing the carbon released in steelmaking, one of the most intense greenhouse gas producers on Earth. Circular reuse and recycling include the upcycling of waste materials into new products, promoting a cycle of continuous use, and greenhouse gas reducing waste management practices like composting. It can include air and water filtration systems, waste-to-energy technologies, and methods for safely disposing of or repurposing industrial waste. Public transit may well be the most cost-effective single way of reducing greenhouse gas emissions. Green construction is substituting low-carbon materials like hempcrete and recycled steel for more climate-destructive materials. Greentech building decarbonization is creating carbon-neutral buildings. It includes insulation, electrification, and on-site renewable energy. Improved heat pumps can produce 3 or more units of heat for every unit of electricity they use. Protecting and restoring ecosystems can rebuild degraded lands, preserve endangered species, and support sustainable agricultural practices. These are only a few of the many examples of Greentech transformations of consumption. More are being implemented every day. Reducing energy consumption can make an important contribution to the transition to climate-safe energy. For example, the IEA's modeling of a world on track to meet the Paris Agreement targets for greenhouse gas reduction shows final energy consumption falling by as much as 15% compared with current levels by 2035, even as GDP continues to grow. That's because of electrification and other energy efficiency measures such as better insulation and heat pumps. As shown in this and the previous commentary, Greentech production and consumption are now far more efficient and therefore far less costly and more competitive than fossil fuel-based systems. This Greentech revolution will have profound effects on the future of the U.S. as well as the rest of the world. Donald Trump and his MAGA allies are determined to reverse the Greentech revolution. Their success would mean catastrophe for the U.S. economy and the American people. Conversely, the Greentech revolution has enormous potential benefits for the U.S. economy and for the American people. Subsequent commentaries in this series will explore what the Greentech revolution means for the American people and how we can take advantage of it